Thank you. Thanks. I'm happy to be here. I wasn't sure exactly how I got invited into this particular group, though it's about the fourth time I've talked at Berkeley. I come up here every few years, it seems. My studio's in Oakland. I've been there for 25 years, and so it's good to come back to the Berkeley campus, which is a really beautiful place. This building's really quite fascinating too. Anyway, I am going to show some work that I've done over the last 20 plus years, and focusing mostly on these robots that I built as sculpture. So since they move, I'm going to show video, and I've loaded all this stuff up on a computer that I've never used before for a talk, so I hope it makes it through. And I'm going to show some other video to start out with, some of my favorite videos, some stuff from the 60s. I was a kid in the 60s, and it seemed to be there seemed to be some formative events that happened back in the 60s, and I was a real little kid in the 60s, and I wonder how it made such a big impact. But then again, I grew up in Ohio, and the 60s there didn't really happen until the 70s. But that's, I think, how I experienced it. And I'm going to show about a half hour's worth of stuff, and then I hope we can talk a lot about it, because really it's most interesting to me to sort of get into the question and answer aspect of it, see what you're thinking, which is really, why I wanted to come here. I'm usually talking to art audiences, which are a little more predictable, at least for me now. And I think this is a really different group for me to talk with. So I'm very interested to get to that part where we can talk. But let me show you.
We're unpredictable but friendly.
Oh, good. All right. So let me show you what I've been up to. And I wanted to show you that 60s stuff that I was mentioning. Actually, I should introduce that. This in the 60s, the arts went crazy, and a lot of really creative things happened. And in the 60s, we had happenings in media art starting and public funding for art. And so what I'm going to start with is a clip of the greatest art piece of the 20th century. It had public funding, and it happened in 1969, but it's really the sort of the biggest media art project ever, and site-specific sculpture in the extreme. So, and I was 9 years old when this happened, and it was fascinating to me.
Right at the last minute, there was a psychological block in there that said, don't count on this so heavily. It might not happen. This is such a big thing.
I think this was the biggest sculpture ever built. And the biggest art project took 10 years to do. And a lot of people
understand as a crewman how to make it work. I could only learn how to operate my share of it.
But aesthetically, as an object, I just think it's
being commander thing that
it's beautiful.
For the first time, begins to bring home the fact that
and it was a kind of
game we've been playing for years.
New visual
they're just going to launch us right straight
experience.
This is Apollo Saturn launch control. All still go on the Apollo mission. The flight to land of the first men on the moon. The spacecraft also now is on full internal power.
I just like all of this stuff as objects. The control panels,
Once we get down to the 3-minute and 10-second mark,
the hardware. Yeah, somehow I seem to recall watching this on TV. But for me, it means so much more now than it did then. I mean, as an art project, which I think is the only way you can explain this. This was an art project, and it was brilliant that they sort of sold it as being useful, which is how you get people to pay for it. So we paid an awful lot for this, which now, of course, there's no funding at all for art. But this really, I mean, to me, it's kind of looking back at an old time when we did have a big war going on at this time, and we had money for doing this. And there was money also for the next thing, which I'm going to show, which is the other art of the 60s, which had a big influence on me, which has to do with excess capacity and military surplus becoming art. I mean, in the 60s, there was just so much excess capacity that we could do things like this art project, and there were other people taking all that military technology, mostly electronics, and employing it for creative means in another domain. Which you should know what I'm talking about by now. This was July 1969, and in August 1969 is the other event that I like to tie in. Which is this. And this again points to excess capacity and having so much machinery that you can do this with it. And it's interesting to repurpose electronics, which was sort of the DARPA's dream of as a military tool. And yet other people saw other potential in electronics. And I think this also points to the idea that all art requires machinery. People think about art and technology as being at separate poles, but really all art is technology. And I mean, here it's more obvious. The same thing is true at an orchestra performance. All musical instruments are machines. It takes a very highly developed technology to make music. And this was just using electronic technology. But I also like the idea that Hendrix, as you can see, is left-handed and plays a right-handed guitar. There's a saying, a craftsman shouldn't blame his tools. So I think he knew how to play guitar, so it didn't really matter whether it was left-handed or right-handed guitar. You just take a right-handed guitar, turn it upside down. Worked for him. So anyway, these were the things I saw as a little kid. And I went off and studied electrical engineering because I thought electronics was really cool. And I thought you could do cool things with it. And shortly after graduating, I moved out to California, where you have so much electronics floating around because of Silicon Valley, which gets to that excess capacity that there's just so much stuff out there to play with. So I'm going to show some clips then of these works I started making in the early 80s. First, with digital video. This is a piece from 1986 called Voyeur. It's sort of the beginning of works I was doing where I made my own digital frame stores. And really in the early 80s there was no digital video at all. It's hard to imagine, but we interacted with computers through a text interface. Computers didn't have graphic interfaces. There was no digital graphics, and it's hard to do electronics that could run at this speed to generate video. So this is not videotape. It's just electronics generating those eyeballs from digital data, so that the object can be a self-contained object. Now this is really horrible video from 1988, shot in analog video, originally on VHS, all these ancient technologies. Anybody remember that stuff? So anyway, this is a piece called Not Broken. And some people might recognize some figures, some people that flash on the screen, even though it's so fast. Anybody see that person? Nixon. Yeah, some people saw it. Good. All right, 1989, nose it all. That's my nose in this piece, before you ask what kind of animal that was. It was easiest to use myself as the model because I was around and I was cheap. But these early pieces, I never really saw the images before I put them into the piece because there were no video tools. There's nothing. I built all my own tools for doing this. It's funny now you think of Photoshop and all these ways you have for manipulating images. But there was nothing back then. So I built all my own digitizers and frame stores and all that stuff. This is a piece called Vanity. I have some very shaky video of it. Using an old cast-off medicine cabinet and a bit of self-portraiture. Family. There's a piece similar to this over at the Berkeley Art Museum. I don't know if it's out right now, but they have one. Sort of like this, from the same time. It has these speakers mounted in these old suitcases where the speakers are moving, they're not making any sound. There's these three suitcases all tied together, chained to these screens with the mouths on it. Now, because there was no videotape, you could do things like this. I think a lot of people thought I was hiding a video decks somewhere. But this piece has a joystick, and you can control the tongue by moving the joystick. But in general, I've stayed away from interactive. Another semi-self-portrait. Yeah, that's me. Now these are CRTs too, which are kind of antiques. You know, actual picture tubes. This is a piece using LCDs instead of CRTs. So a few years ago, started putting flat LCDs into pieces, which changed the work in a lot of ways, just because they're a lot lighter and they have no depth, but they also use less power. The one thing I miss is the surface is flat compared to the curved screen of the CRTs. So I think this is about 5 years old or so. Oh, then multi-channel, about 6 pieces. This piece has been out for about a year over at the De Young Museum in San Francisco.
Are these eyes interactive or are they independent?
They're independent, and they're not following you around. They're just doing their thing. But there's 6 of these 4-inch diagonal LCDs inside what was an old chicken cage. Okay. There, I wanted to get to the dancing robots then. Up through all of that work, I was using some sort of picture screen to do motion on the screen, but the pieces themselves weren't moving. And what I found is that I really liked the object nature of building the structure, and I wanted the whole structure to move. Actually, I wanted the whole structure to move from the beginning, 25 years ago. But I had been waiting to do something like this, which is a full robotic piece, no screens involved, just motion. But really what made this possible, this thing happened when the 486 became available. Before that, you really couldn't do enough number crunching in real time to get the kind of motion I wanted. So this thing is a 6-axis robot, and for every move, it pre-computes a giant array of numbers. So I was waiting for a cheap computer with a math coprocessor, and when the 486 came out, that's really what made this possible. So this piece is like center to center is about 11 feet, from here to there. So those arms are each about 5 feet long. It has a single computer controlling it, controlling both sides. And it goes through this choreography of a dance, which lasts about 15 minutes. And then it repeats, although it doesn't do exactly the same thing. It does a variation on it. And it keeps on every time it goes through the loop, doing variations on this theme, the overall theme being about how these two arms there sort of at the beginning are aloof from each other and become to notice each other and come and interact more. So I will show that video. But really, this is sort of the beginning. This was finished in 95. It was started in 93. It was really just waiting for the computer power to arrive.
Is it mounted vertically or horizontally? Is that on a wall?
It's on a wall. Yeah, this is on a wall. So you're sort of standing out in front of it. Oops. There are no sensors. The arms really don't know. Oh, well, there are home sensors so that it can know a home position, and everything is relative to that home position. But it has no vision of the arms, or no way of sensing where the other arm is. As the software was written in C.
So when you say that one arm notices the other, how does it do?
That's the only the thrust of the programming is this apparent coming together of the arms. Though of course it's a big computer program, and the one computer program is controlling both arms. So that computer program is omniscient. Yeah, knows everything about these arms. There is no music to it. There's just the sound of some motors.
Did you ever try using Intel i960 microprocessor?
I'm not familiar with that chip. I know 386 had a separate 387. 486 moved the math processor inside. All right, well, this was a piece then shortly thereafter where my approach was different. On this piece, by now, well, just at the time I built the other one, microcontrollers were becoming more available. And so this piece is done with a number of microcontrollers. So there's one microcontroller per axis, and there's a network, and there's one master brain. You can see on the floor there's a laptop. So there's actually a master brain talking to one microcontroller per axis. And this is the way I've done everything since then, except now I'm really not even worried about having a master brain. The microcontrollers are good enough to take over. This is what they sound like. You can hear the motor sounds. And that ramping, that pitch change is the ramping up and down, the acceleration and deceleration of the stepper motors. And this is where I went crazy with doing many independent axes. I think this sculpture has 13 or 14 axes, each with its own processor. They're all on the same network. So there's these multiple elements in the space which make up the sculpture. Some are tripod mounted, some are wall mounted, and it's always this communication between them, or exploration, one piece exploring the other. But this thing was just way underbuilt, really, and kind of fragile. And it's a crazy mechanism of sort of like making a giant measuring tape that can unroll. These steel things can unroll. They're about 6 inches wide and 12 feet long. They can roll up and unroll. Nice, I have a pointer. This box had one of those metal giant tape measure mechanisms inside of it. In this piece, these carts are rolling on 40 feet of track. If this were extended straight up, this whole thing would be 13 feet tall. So they're kind of large. I mean, it's about 6 feet tall like this, 7 feet tall. And they go back and forth on the track and do this dance with each other. You can hear the motor sounds. They're getting power from the track, and most of it's fabricated from aluminum. No, but this is actually something we should discuss, because Mark Pauline was definitely an influence on this idea. The thing I wanted to do with these robots is to actually have robots, to have autonomous sculpture. Because I always thought his shows were puppet shows. As much as I liked the work, I mean, it was not robotic. And to me, the key element in robotics is autonomy, that the work can just go out and do its own thing. I mean, all of these pieces I'm showing were in a traveling show that spent a year out there on the road, and it's just the thing of set it up in a room and let it go, and a couple months later put it in a box and ship it on to the next place. So this thing, California Landscape, has one element which is on the track, one element on the wall. Well, it's always so silly to say I didn't like the violent aspect of his work, since basically it was about violence. But I like, to me, I just wanted to see robots as dancing and friendly and, playing. This thing called Inchworm is about 6 feet tall there, and it inches its way across the gallery floor. And the hardest thing about this was keeping it parallel to the wall. And you see it right now making a correction. It lifts itself up on this little ball and just moved itself over a half inch. It's got sonar sensors to measure its distance from the wall. And it didn't always work out that it would keep itself in correct alignment, but it needed to, in order for it to get back to its charging station, because at one end of this travel, there's little metal plates in the floor for it to rest on, for it to recharge its batteries. It's a completely self-contained autonomous vehicle. It's got batteries on board. It's right now going back to the corner, and on the floor back here are some metal plates, and those are the contacts that are going to touch the ground. Now this was taking the thing into a completely, taking it off the track, giving it a whole space to explore. This thing called Rover is interacting with some visitors. It's got a bunch of sonar sensors and passive infrared and a number of processors on board, tries to figure out where it's going. Its main task is not to run over people, not smash into the walls, and get back to its charging station. It similarly has some metal plates on the floor where it can recharge. Here it's going to check somebody out. The sensors on this really were all about avoiding the walls and detecting people. But I guess so. This is, we're putting it out in the environment. Now, all of this work, all of these robots were done sort of in this period from 93 to 98. Well, I'm going to show two more that are just done recently. But basically, I haven't been doing this much. Okay, it's going back to its charging station. This roof is to keep people out so they're not standing here. There's metal plates on the floor right here. There's the metal contacts where it can recharge. Yes, it does. It does while it's recharging. This is a more formal piece of just 5 arms on the wall. Each arm's like that long. That long. This thing actually lives up at the Hess collection up in Napa if you ever go up there on the wine tours. It's just about creating these patterns of these dancing arms. Well, you'd have to go watch it for a while. Random is one of those very interesting words. I don't know which. I never know what people mean when they say that, because random is a very, very difficult thing. No, it didn't really have any history. No. It really didn't know anything about the wall, the room. It didn't map the room. It just avoided the wall and found the.
How do you attack the charging station?
It was in a closed room, so it would eventually get there, following the wall. This is much more recent, of 5 elements on the wall, using feathers this time. So this is about 30 feet of wall space. I've never been there. I'd like to see it sometime.
What's your favorite motor?
Motors, I don't know. I use lots of different stepper motors. I built my own stepper drivers, and I've just done this all with steppers instead of servo motors, though, by the way. Motors, the mechanical work has really not been a problem. In fact, that's why I did it, because I thought it has better prospects for longevity. This is about the latest robot thing that I've done with, again, with feathers. I like these feathers. This is a very strange mechanical arrangement that I built to make that sort of wrist joint. So there are 2 motors per arm. And all these pieces, they have their sort of their choreography. There's really 0 scavenged parts in any of this stuff. There hasn't been for a long time because of just. I mean, it's got to be high quality, usable, a known quantity. Anyway, that's the video that I have to show the work, and I hope that causes you to have some questions, because I'd really like to open it up to questions.
That was fascinating. Very, very different. So what I'd like to do is to walk around with the mic so that everybody can hear the question, starting right here.
So it's wonderful to see robots dancing.
Yeah, no, close enough.
But is it possible that the robots look at the instructor and learn how to dance a new kind of performance? Because maybe it's not so interesting to program one kind of dance, but if the robot can learn a new dance by looking at somebody, then that can be pretty cool.
Yeah. I mean, I think it's a great idea, because you're right that there is a problem in that you don't want it to only do what you tell it to do. But watching it, to get it to be able to watch another dance, I think has a complexity level that I'm really not ready to deal with. But my way of handling that issue is that the software gets more and more and more layers, so that hopefully the software is generative. I mean, there's a point where you have so many layers that the software gets to make a lot of decisions, basically. So that it allows me at a top level to say that I want something sort of like this, and then it goes and it generates variations. I mean, that's sort of where I'm at now. But it is a key point that you don't want to spend all your time in brute force telling it what to do. Definitely, it's a dead end, sort of. Yeah.
Hi, you mentioned that with your early video screens, you didn't have digital video recorders and players, and you were just generating that with your own hardware. Are you still doing that now, or are you just using off-the-shelf stuff now?
Oh, well, I guess I'm a masochist, because I still do it all by myself. I mean, in terms of I'm still building all my own frame stores for my work, but it mostly has to do with wanting it to be completely robust and small and maintainable, and there's an awful lot of other requirements besides just sort of generating the video is sort of the easiest part of the task. I'm more concerned with sort of maintainability and not having my hardware has no operating system. I guess that's the main thing. There's no operating system.
Have any industrial companies approached you about consulting?
They have from time to time, yeah, and I've never done it really. But I did work briefly in industry right after college for a few months. Saw that.
Yeah. Hi there. Have you ever considered using any great work, by the way? Have you ever considered using any genetic or evolutionary computing techniques to have self-learning systems?
I would consider it. I mean, I think genetic algorithms are very interesting. I'm really not much of a programmer myself. I programmed all this stuff in C, and it's pretty basic, and it's just I'm not a programmer. Even though, to me, the programming's just kind of I go out and buy aluminum. I sort of feel the same way about the software. I do it to get the job done, and it's all very easy.
The cool part about genetics stuff is that it programs itself. There are C
Yeah. The thing is, everything I do has to survive in extremely small processors. I mean, I'm using microcontrollers. I used to have about 128 bytes of RAM and 2K of ROM, and that's sort of where everything existed. And that's where I like doing my programming too. Is really very close to the hardware, close to the machine. So.
Thanks. On the theme of playfulness and interaction with people in a space, I'm thinking that whiskers or hair would be a great way, because you could sort of brush along and maybe the person wouldn't mind being brushed a little bit by a few hairs, and you would sense, and it would require very low bandwidth to operate your sensors.
Well, the feathers got started largely to satisfy an engineering problem, and that I was looking for an incredibly strong, lightweight material, and feathers are that. I mean, they are amazing in their strength, and also I love the resilience. And there's something interesting too about that resilience in terms of the kinematics of moving a joint. If you have a rigid body and you try to actuate that whole thing, although it's more easily computable, I mean, it takes a lot more force. When you have a flexible body, it's a lot more forgiving.
I like the juxtaposition of the natural material and the technology. And other than the feathers, the only natural material I noticed was the wood in the cage. So to ask you, did you build the cage for the 6 eyes that's in the De Young? Did you find it? And which came first, the eyes and then the idea of the cage, or did you see the cage and think, eyes go in there?
Since that was a chicken cage, this is chicken and egg question, isn't it?
Yeah, the cage and eye question. The cage I saw at I bought it, and I had been doing lots of sculptures with eyes. For years and years. I still continue to do them. I like the eyes, and often the eyes are in containers of various sorts. And I did see that cage and think, well, I know I'm going to put screens in there, and I wasn't quite sure at that time, I guess, whether it was going to be eyes or noses or what, but it ended up being eyes.
Do you use any chaos math techniques to generate motions? If not, what techniques do you use?
No chaos. It's all pretty simple. I'm computing these motion profiles as far as the acceleration and deceleration for every move, and then it's more into layering. The problem is layering and sequencing all those moves, and those things just get layered up in ways that I can't really explain. I don't know. I mean,
that's what makes it art.
Yeah, I mean, I couldn't really describe what it is. It's something that I've developed over the years, which is my way of doing it. I think of it mostly in terms of language, of how you can, there's C that I've built all these modules in, and then they are sort of, there is a meta language that gets manipulated to form, create the motion.
Have you considered using other engines like hydraulic engines or pneumatic ones? They make different sounds.
Oh yeah. About the other actuators, no. I mean, I've considered it, but I ruled it out. I mean, mostly in terms of mass, that this allows a pretty lightweight system, and I didn't want fluids. I didn't want liquids for hydraulics. I didn't want. Air. You need a compressor. And I didn't really want to be running that. So.
If you ever need to, you've got a civil engineering lab up here. All of this is
Okay. Yes.
What is your aesthetic you're going for? Because we have, pretty cheap. You can get a processor with megabytes and megabytes at least, or gigabytes now. And you could do a lot. You still seem to want to use these little tiny microcontrollers. What's your aesthetic that keeps you there?
There's lots of different things about the aesthetic. In terms of the visual aesthetic, the motion aesthetic. I mean, I don't even know which layer you're talking about, but I will say that one of the most important things for me is that just because something is possible doesn't mean you have to do it, which is kind of the guiding principle in my work. I mean, I could just be, I could do so much more chasing processors, but that to me is not, life is elsewhere. That is not what it's about, and it's certainly not what it's about for me. Yeah, maybe simple is part of that, but it's sort of like I have, I have limited time to do things, and so what's time spent doing one thing is time not spent on other parts, and so I have to be very careful about where I spend my time, and doing it on the processor part is not where I want to spend that time.
I was wondering, you were saying you were held back technologically in the 90s waiting for a processor to come around. Is there something that you have in your mind that you're waiting for a certain technology to allow it to reach fruition? No, not really. It's very odd to me now that all this stuff has kind of zoomed out way off into the future, it seems to me. I mean, when I was in college, processors just barely did a megahertz, and I never would have dreamed that they were operating at the speeds that they're operating at now. And computing power is just so cheap as a tool, to have for laying out my circuit boards and all of that. It's wonderful. And material-wise, I'm always looking for strong, lightweight material, and doing some things with composites now to sort of reduce the mass. But that stuff too is really quite amazing, the strength to weight ratio. So to me that's not, to me already even in college I just thought the technology is way out beyond, that's not where the problem lies. It's like it's a cornucopia of excess capacity. It's way beyond what anybody could ever wish for, So it's really about thinking about what you want to do with it.
Hi. Alan, how would you weight the following in terms of contributing to influencing or inspiring you? And this list would be Alexander Calder, Namjoon Pike, and visits to amusement parks when you were a kid.
Okay. Well, I don't know if you knew Calder was one of my favorite sculptors. Yeah. So I'm a real Calder fan. I don't know how many of you people know Alexander Calder, but you should definitely check out his work. There's one in front of the Berkeley Museum, so you can see it here. Paik was famous for basically being the father of video art. I'm grateful that he basically pulled electronics into the museums, which is very good for me, and though I'm not very much interested in video per se. And amusement parks, well, I hadn't really thought about that, but motion, yeah, I love machinery and motion.
When you program your dances, when you do the motions, what do you like? What steps do you go through to get the dance? Do you think in terms of endpoints? Do you think in terms of like actual motions, or is it done sort of like abstractly, and then once the final program is made, you see what happens?
Yeah. See, this is very hard for me to explain. I don't really have the vocabulary for trying to explain this process, because it is both top down and bottom up. Because I mean, I have to start. I build. It starts years in advance because I build my stepper motor drives, and I think about my stepper motor drivers do have the communication interface built in. So there's sort of this, everything is connected to everything else. I mean, all the decisions about the communications, how the communications can interact with the motion, and just what is the performance envelope of the motor driver, I mean, how many amps it can handle. So there's this very hardware, low-level part of it. And then, yeah, I do have this vision also that wouldn't it be cool if these arms are doing this and that and all that. And that's at this very top level. And there's this whole space in the beginning, in between, which is a whole bunch of software. And I don't really know how to formalize that part, and I kind of have a feeling that nobody in industry knows how either, because I think sort of, in companies there's always the, we'll build the hardware, and sure, the software, the software will do this. People just think that the software will do it. The software can do anything.
We have any questions from the other campuses? Nothing from Santa Cruz or Davis or Merced? One more question? Anywhere? Alan, thank you very much. That was absolutely fascinating.